So today, yesterday we have completed all the cases related to method overloading, which is also called as the compile time polymorphism. Okay, so today we are going to start about the runtime polymorphism. So under runtime polymorphism, we are going to see a topic, okay, topic which is called as the method overriding. Method overriding. So what is the method overriding? The definition is found to be very simple. If a child class has a method which is also present in the parent class. If a child class as a method which is also present in the parent class, it is called as the method overriding. Okay, or else I can say that if a child class has a similar method which is also present in the parent class, it is called as method overriding. So by definition, okay, it is a little bit clear. Let us look into the program. Okay. Let me take a small example. I'm going to take two classes. I have a class A and I also have class B. So inside my class A, I'm taking a simple method. Inside class B, okay, I'm also taking a method M1. You observe one thing here. Okay, the method names are same. Okay, the method signature is same. The return type is same. Everything is found to be same. No difference is here. Everything is found to be same. And if you observe one more thing, these are independent classes, right? This is an independent class and this is also an independent class. Let me take the driver class also. Public class. Okay, I have a driver class. Okay, driver class. What is the driver class? So any class which has the main method. Okay. Take static void main string array. Okay. If you observe one thing, I have two independent classes. So let me put this in the paint screen. Okay, these are my two independent classes, and they have the same method names. Okay. I won't be having any issues. For example, if I create an object for class A obj equal to new A, right? I can specifically call the method that is there inside the class A. I can say obj.m1. The M1 method of class A gets executed. I mean, this method is going to get executed, right? Likewise, if I create an independent object for the class B, obj equal to new B, right? I am being very specific that the method M1 of class B has to be called. This is also very specific because there is no relationship between these two classes. They are independent. They are completely independent. The actual difference happens when I start when I start creating a relationship. The moment I start using the extends keyword. Let me say the moment I start using extends keyword, right? And my class B is extending to class A. Now there is a relation. Okay, what kind of relationship is there? Is a relationship, right? So my class B is here and my class A is here, right? This is my class A and this is my class B, and the extends keyword, right? There is a relationship because of the extends keyword, parent-child relationship. Now you must observe one thing. If you just look at these methods, okay? So I have M1 method inside the class A. I have M1 method inside the class B, right? And if you observe, the method name is same. I mean, method signature is same. Return type is also same. Return type is also same. Okay. And forget about the body. Body can be anything. Inside the body, you can keep any kind of business logic. Okay. Don't worry about the body for now. Body of the method for now. Method name is same, and the return types also same. Right. This is called as what? This picture is called as what? Method overloading. Complete picture is called as what? The method overloading. Right. Okay. The method that is there inside the child class is called as the method not overriding. I mean method overriding. It's called as overriding method. Okay. The method that which is there inside the parent class is called as what? Is called as the overridden method. Overridden. Right. So to apply this method overriding concept, you must definitely have the parent-child relationship. First thing, that should be an inheritance relationship. Right? Inside the inheritance relationship, if you inside each and every independent classes, if you the classes that are related to each other, if you have the common methods, like the method name should be same as well as the return type should also be same, then you can say that these methods are overriding methods. Let me write a simple logic here. Okay, method of class A. Let me write a logic here. Method of class, right? Let me create a relationship. Right? Now I have three options to do the object creation. What is the first option? I can say a obj1 equal to new a. A parent to parent object is being created for the parent to parent. I can also say b obj2 equal to new b. Okay, child to child. I can also say a obj3 equal to new b, parent to child. Okay, objects can be created in three ways, right? The moment I have a relationship, when two classes are in a relationship. So these are the three ways, right? So with the help of obj1, they call method m1. Okay, what would be the output? With the help of obj2, they call method m1. What would be the output? With the help of obj3, they call method m1. What would be the output? Right? So this is the case study. Okay, let me put this in the paintbrush. Okay, let me put in the page. This is the actual code, right? So what I am trying to do here is I am calling the M1 method with three different reference variables, object reference variables. Three different object reference variables, right? Three objects are created. So with the obj1, I want to call M1. With the obj2, I want to call M1. With the obj3, I want to call M1. Now understand the control flow here. Now understand the control flow, right? Firstly, I am calling what? I am calling obj1. obj1 is a reference variable of what type? A type. Okay, no doubt the control will directly get transferred to the class A. Control will directly get transferred to the class A. Okay, and M1 method of A will get executed. No issues. Likewise, when I try to call the method M1 by using the reference variable obj2, okay, identify obj2 is of what type? Obj2 is of class B type. Okay. Definitely the control will go to the class B, and the M1 method of the class B will get executed. Right? And what is the third type? Third type is what? Third type is obj3. Right? obj3 is a reference variable. obj3 is of what type? A type. Okay? Now the question is, which M1 method will be called? This M1 method will be called, or this M1 method will be called? This is the question. This is the interview question. Right? In the overloading concepts, what I have mentioned in the overloading concept, the overloading concept, it is always called as the compile time polymorphism. So the left hand side will be given the priority, the type will be given the priority. Okay? But in the overriding concept, okay, I am specifically saying about the overriding. The overriding concept, okay, whenever I am doing the upcasting, right, whenever the object is being created with the help of upcasting, okay, child object with the parent reference, right, the priority will be given for the runtime objects. The priority will be given for what? Runtime object. Runtime object means the RHS side, right hand side, runtime objects, right? So if I make a call by using obj3 dot m1, definitely the output has to be what? M1 is of, we know that obj is of obj3 is of A type. No, you don't take the type, you take the object. What is the object? Object is new B. Okay, So the B class M1 method will get executed. This is why it is called as what? This is why it is called as the runtime polymorphism. The JVM will make a decision which method needs to be called in the runtime. That's what it is called as what? Runtime polymorphism. Completely opposite to the compile time polymorphism. Okay, this action will be applied only when two methods are there is an overriding concept in the inheritance. Only if there is an overriding concept. Overriding means when the parent class has the same method as the child class. Okay, so that's what is called as what? Runtime polymorphism. Okay, let me execute a small code. Okay, now we have this piece of code, right? Let us validate our changes, whether it is really happening or not. Okay, Java C space driver dot Java space. Okay, method 1 of class A, method of class B, method of class B. Right? Always the runtime objects are given priority. You are using what? The object is created for class A, right? M1 of class A will be called. So this will be the output the console runtime, right hand side. Okay, the object is being created for class B, right? M1 method of class B will get executed. Here also the object is being created for that. Don't look for the type for overriding concept. Look for the type only in the overloading concept, not in the overriding. Overriding is nothing but the runtime polymorphism. Object is being created for the class B, right? So M1 method, even though the type is A, to which the object is being created for the class B. So M1 method of the class B is going to get executed. Making sense, everyone? Yes, no? Say something. This is a basic understanding about overriding. We will see a lot of interesting case studies here. Lot of beautiful case studies are there. So this is a basic idea about overriding. Okay. Now you tell me, okay, you have to answer me whether it is possible or not possible. When I say, I have a class A, guys. In my class, okay, I have something like void M1. Okay, I have two methods, void M1. Tell me, is it possible or not possible? What kind of concept is this?
Not possible.
Not possible, because this method will be treated as the duplicate methods. Within the same class, if you place some methods in duplicates, okay, there are any duplicate methods that will be treated as what? That will be treated as a duplicate methods. But if I ever want to do like this, okay, let me say I am taking another independent class which is class B. Okay. If I remove this and if I place it here, valid or invalid this one?
Valid, sir.
This is valid because both are independent classes. Both are independent classes. No matter the method names are same. Okay, there is no conflict here. There is no conflict here. If I start, class B extends class A. What kind of concept is this? This is what? The overriding concept. You might be thinking, okay, there is a class A. Let me do it in this way. You might be thinking, right? You might be thinking, okay, so this is class A, and this is class B. Okay, class B is extended to class A, right? So the method M1 is also there in the class A. The return type is also same, right? This will not be considered as a duplicate. Instead, this will be considered as what? The method that is there in the parent class will be considered as the overridden method. The method that is there in the child class will be treated as the overriding method. Making sense, everyone? Yes, no? One more thing. If you are dealing, okay, for the method overloading, you will deal with the same classes. Within the same class, you will deal with the concept of method overloading. Okay? But for the method overriding, you will have to deal with the two different classes which has the inheritance relationship. Right? There should be an inheritance relationship to apply the concept of method overriding. This is a takeaway. Right? For overriding, there should be an inheritance relationship. For overloading, no such relationship. Within the same class, you are going to deal with overloading. Understood or not till now? Yes, no?
Yes, sir.
Yeah, now see, let us increase the complexity. Now, what I am trying to do here is, let me remove all these things. Okay? Let me show the real-time example. Okay, I am removing this also. I am removing some realistic example I will show. Okay, I have class A, I have class B, and I have I also have class C. Three classes I have. These three classes are independent classes. Three classes are independent class, and there is a fourth class which is a driver class, main class. Three independent class I have, right? And what I'm trying to do is, let me create an object for class C, obj equal to new C. Okay. So what I want to do now, I want to say system dot out dot println. Okay. If you print obj, definitely some garbage value will be displayed in the console, because internally we know, we have discussed these things in the during the beginning of the class, Java classes. Okay. Internally the compiler will call the toString method, okay. And this toString method will return something, okay, something, and that will be captured and displayed in the console. Let us see what is there in the console. Java C space driver dot Java space. So some garbage value, you are getting this in the this as the output. Now see what is actually happening here. This is very important, focus here, very interesting also. Where and all you can see this overriding concept. So this is one of the realistic examples. Okay. These are our simple, very simple class. I can say three independent classes, no relationship is there. If I ever had to create the hierarchy, diagrammatical representation, okay, I have three classes, right? Can I say I have three classes? Okay, this is my class A, and this is my class B, and this is my class C. Okay. And if I am not extending my class to any other class, so internally compiler will extend it to what? Extend it to object class. Yes or no? Do you agree with? Every class will be extend to object class. So this is class A will extend to object class, class B will extend to object class, and class C will get extend to object class. So this is what the internal things are, right? I can also say that object class is mother of all the classes, or the object class is super class of all the classes. So this is how the hierarchy is going to be. Okay, for the object class, with our code representation, I can say that A, B, C are children to object class. Right? Now focus here. So in the control, okay, in the main method, the object has been created for the class C. Okay, definitely object will be created for the class C, and the reference variable is what? obj. Okay, and in the system dot out dot println, okay, I am just trying to print the obj itself. I want to print obj itself. We are getting some garbage value, right? You will understand the flow. Internally, what compiler will do? Compiler will call the toString method, obj dot. There is a method called toString method. Going to call. However, but where is this toString method? I don't see toString method in the class C. I don't see toString method in the class C. So how the control flow, how the control will be traversed? Okay, from here, the call will go to what? Call will go to class C. It will find, the control will try to check, is there any toString method in the class C? Of course, there is no toString method. Then it will jump to the object class. It will jump to the object class. Inside the object class, it will try to find the toString method. Of course, there is a toString method inside the object class. This is how this toString method is. Okay, there is a method inside the object class. So this is the prototype. Okay. It will return what? It will return some kind of garbage value. Let us say something like hexadecimal number. Class name at the rate some hexadecimal number. That's internal. Okay, you are seeing the hexadecimal number. Even though there is no toString method, but however you are able to see something in the console just because of what? Because of control is getting traversed to the toString method of the object class. Right? Likewise, if I say something like the obj new build, okay, now obj is of what? A B type. Inside the class B, there is no toString method. However, the class B is extending to the object class, right? The object class toString method will get executed. Okay, Java C space driver dot Java. Okay, Java space driver. Now you get something like this. The idea is, what I am trying to do, I do not want to display, I do not want the JVM, main thread, to execute the toString method of the object class. I don't want to execute toString method the object class. I want to make sure that the control is not going to the toString method of the object. What I can do, take this as an example. Definitely, first the control will jump to the class B. It will try to check for the toString method inside the class B. So let me keep my own toString method. Okay. Let me say the return type is string. Let me say the access modifier is public. Okay. Let me return something like my toString method of class B. Okay, now let me execute this. Java C space driver.java. Java my toString method of okay. What is happening? What is really happening when this? To understand the flow here. Right. Let me separate the main method for better observation. Right. See now. See guys. So now focus only on these lines. Okay. Object is created for the class B. I want to print obj, right? So internally compiler will call okay obj dot toString method. However, the control will travel to what? Control will travel to the class B. Why? Because obj is of what type? Obj is of the class B type, right? It will go to the class B. Okay, so this is the class B, isn't it? This is the class B. It has found the toString method here. Right? And again, in the object class, okay, so the moment you start using the extends object, okay, we are not using it. Internally, compiler is adding this extend object class for all the classes since the class is not extending to any other object explicitly. Any other parent, I mean, it is not having any other parent explicitly. So compiler will add this thing, extends object, extends object. Okay. So somewhere, okay, let us say that this is an object. Object, class, object. Okay, object class has 11 methods, okay, and one of the method is toString method. It has totally 11 methods. 11 methods. One of the method is toString method. One minute. My screen is perfect. So one of the method is toString method. So toString method will be like this: public string toString. It will return. Okay, some logic will be there inside. Okay, some logic will be there inside. Logic will be there inside, and it is going to return a garbage value. Okay? Something like class name. Okay, at the rate some hexadecimal value. That's it. Right now, you tell me. Okay, I have placed my own toString method inside the class B, right? And there is a toString method inside the object class. There is also toString method inside the object class. Can I say that okay, this method is the overriding method. This method is called as what? Overriding. Okay, and this method is what? The overridden method. Can I say that? The priority will be given to the overriding method, so that's why this is getting executed. Making sense? Let me give you another example. Okay, now see, let me increase the complexity. Let me say I have a relationship between all the classes. Class is extending to B, class B is extending to A. Okay. Now if I create an object for class C, obj equal to new C. Now can anyone tell me what would be the output? Can you think and tell me what would be the output considering the relationship here? Can you guess?
Hexadecimal number print.
No. Okay. Good try. But see, Java C space Java space my two-string method of class. Now what is happening here? So this is what the highlight here is. Okay, what is happening here? See, obj definitely you are right in some way. Okay, it is going to call the two-string method. Okay, firstly, it will try to find the two-string method. Okay, obj is of what type? C type. It will try to find the two-string method inside the C class. Okay, unfortunately, two-string method is not in the C class. Then it will use the extends keyword. It will jump to the class B. But in the class B, there is two-string method. No, this will get executed, right? Are you getting? You're not allowing the control to traverse to the object class to execute that method. Here you are placing a block because this is overriding. So this is the inheritance. First is okay. Let me keep it here. Okay, keep it here. Now you tell me what would be the output.
It will return a classification. The micro is
Yeah,
important.
same thing. You understood now? Now, anyhow, object is created for class C only. Okay, I'm agreeing with that. First, the control will try to jump, find the two-string method inside the class. First priority will be going to class C. It's not there. If you use the extends keyword, it will jump to class B. To try to find two-string method, it is not there. If you use the extends keyword, it will jump to class A. Just found the two-string method. Just found the two-string method. Now, definitely, what should be the output? This should be output. Now, you tell me what would be the answer. If I just break the relationship, now you tell me.
Hexadecimal number.
Now, hexadecimal number will be printed. Now, definitely, hexadecimal number is going to come into the picture. Why hexadecimal number? Because it will check in the class C. It will go to class B. Okay, at last, okay, it will go to the object class. Object class two-string method will get executed. That is the proof. So here is the proof. Object class two-string method. Okay, now you tell me. So now see, now what I am trying to do here is, okay, this is possible. No? This is possible or not possible? Can I say that object is the superclass of all the classes? Right? For the class A, the compiler will extend it to object class. I can say I can keep the type as parent. The type can be parent, and the object can be created for the child, which is what? Which is A. Yes or no? Right? I've been telling you about the runtime polymorphism. Okay, whenever you are calling a particular method which is overriding, a priority will be given for the RHS side, runtime polymorphism. Considering that, okay, I have the two-string method. Definitely, this is of object type only. Control, we will be thinking that control will be jumping to the object class. But what is there in the RHS side? Two-string method is there in the RHS side, right? This will get executed. Are you getting? Okay. The beginning of this class, I will explain this to you. Let me repeat this once again. Whenever you get this kind of questions, okay, try to create a diagram. Okay, try to create a diagram. How the diagram can be created here? So it can be created like, okay, there is always an object class. The object class is there. In our example, for the object class, A is child and B is also the child. Can I say? A is a child. Okay, B is also the child. Okay, now think, okay, and C. When it comes to C, for C the parent is what? For C the parent is B is the parent. This is the relationship. For C, B is the parent. Okay, and for B, object is the parent. Okay, and for A, object is the parent. So this is the hierarchy. This is the diagrammatic representation. Right? For the object class, A and B are children. C is the grandchild. Right? I can, if I create an object, if I can create object like can create an object like obj o equal to parent type to child reference. This is possible, no? Okay, this is also possible. Obj o1 equal to new b. This is also possible. Right? So with the help of o reference variable, okay, with the help of o reference variable, if I call toString method, right? ToString method is there inside the class A as well as it is there inside the object class. We agree? Inside the class A, we have ToString method. Somewhere inside the object class, there is a ToString method. We agree this? Yes, no?
Yes, sir.
We agree this? In the object class also ToString method is there, which we don't see it, but it is there. The library it is there. Right? I have been telling you about the runtime polymorphism. If you encounter this situation, okay, if I am trying to execute the ToString method, okay, don't go by the type. Okay, don't look for the type. Don't look on the LHS side. Look on the RHS side. Runtime polymorphism. This RHS side or runtime. In the runtime, which object you are creating? A object you are creating. So the ToString method of A will be executed. Are you getting? Yes, no?
Yes, sir. Yes, sir.
Now you tell. Okay, this is one of the examples. Now you can create an object like this. Another example. Like object B equal to. Is possible or not possible? Possible. By looking at this, we can say this is parent, this is child. Definitely, this is possible. If I call toString, if I say B dot toString method. Now try to understand one thing. Consider this class, okay? Consider the object class, consider the B class. Okay? Is there B in the B class? There is no toString method. ToString method is not at all there. So there is no concept of overriding here. When there is no concept of overriding, okay, then the ToString method, you have to look for the type. Don't get confused. When there is no concept of overriding, the execution will be happening with the help of type. So the object class ToString method will get executed because in the class B there is no ToString method. Okay, let us say if I start creating a ToString method inside the class B, I start placing a ToString method inside the class B. Let me say I'm placing this method in the class B. Now how it is going to be? Now you have found that okay, ToString method is there inside the object class and it's also there inside the class B. Now we execute ToString method by using the reference variable. Now the runtime polymorphism will happen. Now this will get executed. Are you getting? Yes, no?
Yes, sir.
Right? We will see one popular example. To understand this better, instead of doing these things, okay, I will keep it a bit simpler. Let me say I have the void from one here. Okay. Dot print. Okay. Let me print A1 here. We will take only two classes, okay, class A and class B. We say void M1 here. Okay, let me say class B. Right now, this is M2 method. This M3 method. This is A1. Let me say this is B1. Okay, so I have two classes. Okay, let me remove this. Let us extend the class B2. Hence, let me take this piece of code. Right. Now focus here. So it is very straightforward. That I have class A and I have class B. Both are in relationship. So when both these classes are in a relationship, and again, okay, this A will be what A will be extending to the object class. So we are not dealing with the object class now. Right. So let us say that I am creating an object for the class B. B obj equal to new. So with the help of obj, I can call the I can call m1 method, I can call m3 method, I can call m2 method, but I cannot call this m1 method. Why? This m1 method cannot be called. Why? Because this is the overridden method, right? This is the overridden method. Overridden method. This is the overriding method. Overriding method. Right? If I call, if I call m1, okay, this will get executed. M1 of class B. Even though if you look at the type also, this will get executed. If I call m3, okay, this will get executed. Call m3. Okay. Now, what happens if I call m2? If I call m2, control will just try to look for the m2 method inside the current class, which is inside the B class. Then it will jump to the A class. Then it has found the m2 method. This will get executed. We do not have any issues with this. Likewise, if I have created an object for class A, obj equal to new. With the help of obj, I can call m1, I can call m2. When I call m1, we look for the type. Because the object is created for A only and type is also A only. Definitely, okay, m1 method of, even if you look at the runtime polymorphism, m1 method of this will get a class A gets executed. If I call m2, m2 method of class A get executed. Okay. I cannot call what? I cannot call, m3. Right? M3 is part of class B, so this cannot be called. Okay, now the question is, I can create an object like this. A obj equal to new B. Child reference, child object, parent reference. They called obj dot m1. The control will try to check, okay, m1 method, okay, is the m1 method is there in class A? It is there. It is also there in class B. It is also there in class B. It is there in both the classes. Sorry. There in class A, it is also there in class B. Okay. So which method will be given priority? Okay, runtime. Okay. RHS side. RHS is what? What? New B. Right? So the B class will get priority. Okay, this will get executed. Right? And okay, you can call m2. Okay. It will check. Okay, m2 method is there in class A. Yes, it is there. Is it there in class B? No, it is not there in class B. Right? So this will get executed. Right? If I try to call m3, it is not visible. M3 is very much specific to class B. It's very much specific to class B. Okay, this method cannot be called. Cannot be called. This is the only difference with the upcasting. Upcasting. Making sense, everyone? You get what I'm trying to say.
Yes, sir.
Right, now you tell me the answers. Okay, let us. You tell me. Object A equal to new B. Okay. So what I want to do? I want to call A dot. Think and tell me. A dot m. Tell me. So this is for the first time. It will be a bit confusing. Okay, when you start practicing, things will be very much clear. Look at the types first. Okay, this is upcasting. Let me give you a code. Okay, let me give you a code. This clue. I will give you a upcasting. Upcasting means okay, overriding and overridden method. Okay, it will always look if there is any overriding and overridden method. I mean same method, similar methods. Okay. If this is found, priority will be given for that particular method. So this is not even the case. Okay. M1 is what? M1 is there inside the class B, but they are not overriding or overriding. So this case study can be ignored. Second thing is, only the general method of the object class can be executed. Object class can be executed with a reference variable, not the specific methods of the child class. Because M1 is the specific method of the child class, isn't it? This cannot be executed. It cannot find symbol error term. See guys, if I create an object for the type is B, this is valid. Okay, I can M1 is visible. M1 is visible if the type is B. The type is like object. I mean, if the type is like the parent class, if the object is created for the child, okay, the methods which will be executed are overriding or overridden methods will be executed, or all the the general methods inside the object class. Are you getting what I'm trying to say? Yes, no. There are restrictions placed for the specific methods inside the class B. So if I take this as an example, we are dealing with what we are dealing with. Don't get confusion with this extents here. Okay, let me just take only this class. Take this class B. Okay. So I am extending to class A. Okay, no issues. Okay, I have a class B. Okay, I am extending to class A. Again, this class A is extending to object class. Okay. The parent class object, the parent or grandparent object. This is a grandparent object. Okay. This reference this type can be kept for the grandchild class object. No problem. This is no problem. What I am trying to say is, in the object class, okay, there are 11 methods. 11 methods. These 11 methods can be executed first of all. Plus, okay, this reference variable can execute all the 11 methods inside the object class. Second, okay, if there is any overloading or overriding methods, if there is a similar method from the parent class as well as the child class, from the grandparent class as well as the child class, similar methods. Like for example, if I place a toString method inside the child class, it is a similar method which is also there in the parent class. So overriding concept is applicable here. Okay. Now the child class toString method will be given priority. Second case. Okay. But no specific methods of the child class will ever get executed. Okay. So this M1 method is very specific to class B. This M3 method is very specific to class B. So this M1 and M3 will never get executed. And M3 is not visible actually. Are you getting what I'm trying to? This is the what we call it as this is the case study, I can say. These are the points that you have to remember. Are you getting? Yes, no? Any confusion? Okay, let us go by the very simple program. Okay, I think this program is actually creating the complication. Okay? Now what I want to do? Yes. Now let me remove this. Now you tell me this. Okay, A obj equal to new. Tell me, is this possible or not possible? Okay, this is class A. Okay, this is class B. Okay. So B is the child of class A. Possible, no?
Yes, sir.
Upcasting, right? Okay. Now the question is, with the help of obj reference variable, if I call M1, what would be the output? First think, okay. Now think, okay, M1. Okay. Is the M1 is there in the class A? Yes, it is there. Okay. Is it there in class B? Okay, it is also there in class B. Now this is overriding method, this is overridden method. So what is the runtime object? B. So B class method will get executed. Yes or no? Output should be B. Yes or no?
Yes, sir.
Right? If you see Java C space driver.java, output is B. Right? Now, if I call m2, is it possible or not possible? Possible. Okay. Why possible? M2 method, right? M2 method. OBJ is of what type? A type. Okay, first it will check. Okay, M2 method is there in class A or not? Of course, M2 method is there in class A. M2 method is there in class B or not? M2 method is not there in class B. Right? So, this M2 method of class A will get executed. The general method of class A will get executed. So, this has no issues. A1. Right? The problem comes when I try to execute M3. First, it will check M3 method is there in class A. It is not there. It is not there. Okay, this will not get executed. This is very specific to class B. Let me execute this. See, cannot find symbol. It is not visible actually. The specific methods of class B will be blocked. I can say that specific method of this class B will be blocked. Only the overriding methods can be accessed from the class B, and all the general method of class A get accessed. Are you getting what I'm trying to say with upcasting? Yes, no.
Yes, sir. Yes, sir.
Right? Okay, now you tell me. Okay, let me do this. Just for the just to check whether you are getting this or not. Now, okay, I want to execute what? I want to execute. That's are visible now. I want to execute M1. What would be the output?
B.
M1. Okay, correct. Good. B will be printed because runtime polymorphism. M1 will be checked in both the classes. Okay, it has found in both the classes. Okay, in the runtime B is there, no? So B will be given priority. Good. Okay, this is something different error. Okay, not related to our code. I think some closed. This is closed. This is also one additional thing to say. Let me execute. B is printed. Let's try to do M3. Now tell me valid or invalid. What would be the output?
B1 will print.
Correct. B1 will be printed. Now we are getting both. It will check in both the classes. Okay. If it has found in both the classes, then priority will be given for the runtime object, which is B. Okay. Now tell me what would happen if I print something like M2. What would be the answer? Yeah, A1 will be printed. Correct. A1. Okay. Now you tell me what would be the output if I try to print. That's it. Okay, everything can be executed because these both are overriding method. If I take something like M4 here, okay, instead of M4 here, if I try to execute M4 here, now is it valid or invalid? Invalid because this becomes invisible. That's what I'm trying to say. Okay, overriding methods will get a chance. Only the overriding method of class B will get a chance. Or I can say that all the methods of class A except for overridden method will get a chance, but not all the specific method. I can say that. We put it in a theory. Upcasting. Overriding methods of class B will get executed. Okay. Overridden methods of class A will not get executed. Or else I can say that except the overridden methods of class A, all the remaining methods of class A gets executed with the reference variable obj. Okay. only overriding methods of class B will get executed with the reference code VJ, not the other methods. Making sense now, this theory? This is applicable only for this upcasting. Getting? Yes, no?
Yes, sir.
Hello?
Yes, sir.
Right? Okay, so this is the basic idea about the basic foundation level concept of overriding. Okay, there will be a lot. There are a lot of beautiful cases in the overriding. A lot of popular interview questions are there, okay, which are really confusing. We will discuss each and every topic in detail in the tomorrow's class, so that we'll get much comfortable in the overriding concept. Right? Only when you understand this overriding and overloading, most of the 70% of the Java applications depends upon this polymorphism concept. Okay? And if you want to understand the abstraction and interfaces, which are the next. I mean, after completing this, we will start abstractions, right? Over there also, we will be depending upon this overriding. Very much important for developing Java application. And not only this, I have said, as I have already said, encapsulation, inheritance, as a relationship, and overriding. Overriding is also important, but you don't use it very often, but overriding is very popular. We'll see a lot of case studies tomorrow, then you will feel much comfortable. Right? So that's all.